Hello student, in 11th standard in the topic redox reactions you have studied that redox reaction is a reaction where oxidation and reduction reaction takes place simultaneously. Oxidation reaction cannot take place separately or only reduction reaction cannot take place. Both the reactions are taking place at the same time, that is one substance loses electron, at the same time another substance gains these electrons. Now if you have to measure the potential of any single electrode, it is not possible due to this reason, because only single electrode, in single electrode either oxidation reaction will take place or reduction reaction will take place. Oxidation reaction cannot take place separately or reduction reaction cannot take place separately, so you cannot measure the single electrode potential. But if we construct a cell by using oxidation electrode and reduction electrode, because cell is the combination of oxidation electrode and reduction electrode, you can measure the cell potential experimentally, and by knowing the cell potential you can determine the electrode potentials. But remember here, the cell potential of the cell, which is represented by E cell, and if it is standard then it is represented by E0 cell, is the summation of E0 oxidation and E0 reduction. That is the potential, oxidation potential which takes place at oxidation electrode or at anode, plus the reduction potential which takes place at cathode. So it is the summation of oxidation potential and reduction potential. If we know the oxidation potential and if we determine the E0 cell by experiment, then you can calculate E0 reduction. Means remember here, if you know one of these two values, then by determining E0 cell you can calculate the remaining value. For example, suppose we have or we know the oxidation potential of the electrode and reduction potential you have to determine. Now you can't calculate reduction potential separately or you can't determine reduction potential separately. What we have done? We have constructed a cell by using these two electrodes. In these two electrodes, one of these electrode, the potential of this electrode is known to us, and we have constructed a cell. The cell potential we have determined by using this value and this value, you can calculate this value. Means remember here, we require one electrode whose potential is known to us, and that potential, that electrode is called as reference electrode. Remember here, what is the reason for using the reference electrode? The single electrode potential cannot be determined separately. Why? Because oxidation reaction or reduction reaction cannot take place separately. Both the reactions takes place at the same time, and so if you have to determine the single electrode potential, suppose we have to determine zinc electrode potential, suppose we have to determine zinc electrode potential, then this zinc electrode is connected with another electrode whose potential is known to us, and then a cell is constructed and the potential of this cell can be determined experimentally, and you can calculate the zinc electrode potential. Now the chemists use standard hydrogen gas electrode as a reference electrode, and that electrode is called as primary reference electrode. Primary reference electrode. And primary reference electrode is only one, and that electrode is standard hydrogen electrode, which is SHE. It is represented by SHE, that is standard hydrogen electrode. Here you know that electrode potential is the measurement of the tendency of the electrode to get oxidized or to get reduced. Now here, if the reduction potential is more, you can say that the element has more tendency to get reduced. If the electrode potential or the potential reduction potential is less, you can say that the element have less tendency to get reduced. Like this, hydrogen, if you consider H plus ions and H2 molecules, how hydrogen electrode can be prepared? You know the condition, hydrogen molecules must be in direct contact with H plus ions. If hydrogen H plus ions are in direct contact with H2 molecules, these ions have very less tendency to get reduced, and this tendency is considered as zero. This tendency is very less. That is, the tendency to H plus ions to accept the electrons and get converted into H2 molecules is very less, and so this is considered as zero, and so the standard hydrogen electrode potential is arbitrarily fixed as 0 volt. It is arbitrarily fixed as 0 volt. Now remember here, primary reference electrode is standard hydrogen electrode, and standard hydrogen electrode potential of this electrode is arbitrarily fixed as 0 volt. But at all the times, the standard hydrogen electrode cannot be used as reference electrode. Here, by using standard hydrogen electrode as reference electrode, the potential of another electrodes are fixed, and these electrodes can be used as reference electrode, and they are called as secondary reference electrode. The secondary reference electrodes are here calomel electrodes or silver electrode or glass electrode. These are secondary reference electrode. Why these are called as secondary reference electrode? These are used as reference electrode, but their electrode potential is determined by using standard hydrogen electrode as reference electrode. Remember, if you take any electrode, suppose we have calomel electrode, the calomel electrode potential cannot be measured separately. It must be constructed with another, it must be connected with another electrode. Then standard hydrogen electrode is connected with calomel electrode. The potential of standard hydrogen electrode is known to us because it is arbitrarily fixed as 0 volt. The cell is constructed from EMF of this cell. Here the potential of calomel electrode can be calculated, and here this calomel electrode can be used as reference electrode for the calculation of potential of different electrodes. So these electrodes are called as secondary reference electrode. You can understand what is the difference between primary reference electrode and secondary reference electrode. Primary reference electrode is standard hydrogen electrodes whose potential is arbitrarily fixed, and secondary reference electrode, their potential is known to us, and so reference electrode is an electrode whose potential is arbitrarily fixed as 0 volt. The potential is arbitrarily fixed as 0 volt, or it is known to us, that electrode is called as reference electrode. Remember, the electrode whose potential is arbitrarily fixed as 0 volt or whose potential is known, that electrode is called as reference electrode. Standard hydrogen electrode is called as primary reference electrode. The electrode potential of this electrode is arbitrarily fixed as 0 volt. By using standard hydrogen electrode as reference electrode, the potential of different electrodes can be determined, and some electrodes are used as secondary reference electrodes. Now we shall consider the standard hydrogen electrode in detail. Here remember that hydrogen gas electrode can be prepared by using the condition hydrogen gas molecules, they must be in direct contact with H plus ions. You know that here, if you have to prepare any gas electrode, the gas is adsorbed because you cannot make the rod of the gas. So the gas is adsorbed on the inert metal like platinum, and that platinum metal is dipped in a solution containing the ions of the gas. So for the preparation of gas electrode or hydrogen gas electrode, we require hydrogen gas, the solution which contains H plus ions, and platinum metal foil. Now if we have to make this hydrogen gas electrode standard, then we have to follow these conditions. The hydrogen gas we are using must be pure and dry. You can prepare hydrogen gas electrode by following this condition, that is hydrogen gas must be in direct contact with H plus ions. Hydrogen gas is adsorbed on the platinum metal. But here remember that to make this electrode, standard electrode, we have to follow these conditions. The hydrogen gas we are using must be pure and dry, and the pressure of this gas must be 1 atmosphere. The H plus ions we are using, that is the solution containing H plus ions, here the concentration of H plus ions must be 1 molar. And here the platinum plate must provide the larger surface area, and so it is called as platinized platinum foil, or this platinum foil is covered by platinum black. By following these conditions, we can construct standard hydrogen electrode. We shall see the construction of standard hydrogen electrode by considering the diagram of standard hydrogen electrode. See the construction of standard hydrogen electrode. Here there is one platinized platinum plate. This is platinum plate which is covered by pure platinum, which is called as platinum black. You know that here we have to adsorb hydrogen gas, and adsorption is a surface process, and so it depends upon surface area. So to increase the surface area, this platinum surface is made rough by covering it with pure platinum. So this is called as platinized platinum plate. This platinized platinum plate is connected to the external circuit by this copper wire through this narrow glass tube which is sealed. This is the glass tube which is sealed. In this glass tube, at the bottom, mercury is added for the electrical contact. Now this glass tube is covered by glass jacket. This is glass jacket. See here, this is glass jacket which has one inlet for hydrogen gas. Here there is one inlet for hydrogen gas through which we have to pour the hydrogen gas at 1 atmospheric pressure. This platinum plate is inserted or is dipped in a solution which contains H plus ions having the concentration 1 molar. Now here when you pass hydrogen gas at 1 atmospheric pressure, this hydrogen gas is collected on this platinum plate, and these hydrogen gas molecules are in direct contact with H plus ions. So the condition for the formation of electrode is fulfilled here, and so this construction is called as hydrogen gas electrode, and it is standard hydrogen gas electrode because the gas we have passed is at 1 atmospheric pressure and the solution we have taken is of 1 molar concentration. Like this we can construct standard hydrogen gas electrode, and it can be used to measure the cell potential by connecting it with another electrode. Suppose we have to measure the potential of zinc electrode. Now how zinc electrode is made? By dipping Zn rod in a solution containing Zn plus ions. We have taken 1 molar ZnSO4 solution and Zn rod is dipped in it. This electrode, this zinc electrode is connected to standard hydrogen electrode. Now this is the construction for standard hydrogen electrode. Now these two electrodes will form a cell, and the cell potential can be calculated or can be determined experimentally. You know this construction, this is, you can say, the cell, or it is voltaic cell in which zinc electrode or zinc half cell works as reduction electrode and hydrogen gas electrode works as zinc electrode works as oxidation electrode or anode, and hydrogen gas electrode works as reduction electrode or cathode. These two electrodes are connected by using salt bridge, and so if you measure the potential of this electrode here, it will be only due to the potential of zinc half cell, because here standard hydrogen electrode potential is 0. And so remember that if we have to determine the potential of any half cell, standard hydrogen electrode can be used as reference electrode. But there are some drawbacks of this electrode. We shall see these drawbacks afterwards. Now, how this electrode can be represented? This is called as formulation of the standard hydrogen electrode. Here H plus ions are there. The concentration of H plus ions is 1 molar. You can say here aqueous, single vertical line. Hydrogen gas, the pressure of hydrogen gas is 1 atmosphere, and this hydrogen gas is in direct contact with platinum. So this is the representation of standard hydrogen electrode. Here H plus ions having the concentration 1 molar, aqueous, H2 gas, the pressure of this gas is 1 atmosphere, and this hydrogen gas is adsorbed on platinum metal, which is the reaction which takes place in this electrode. Now H plus ions are there. By accepting the electrons, these ions are converted into H2 molecules. So the reaction which takes place in this electrode can be represented like this: 2H plus aqueous plus 2 electrons gives hydrogen gas. Which is the application, or which are the advantages of this standard hydrogen electrode? Now, by using standard hydrogen electrode as reference electrode, you know that E0H2 is equal to 0 volt. Now suppose I have said we have to construct a cell by using zinc electrode and standard hydrogen electrode as a reference electrode. Now standard hydrogen electrode potential is 0. The summation of these potentials will be equal to E0 cell. Now as this value is 0, the EMF of this cell will give you directly the potential of this electrode, that is zinc electrode. The EMF of a cell is equal to the potential of this zinc electrode. Like this, by using standard hydrogen electrode as a reference electrode, you can directly calculate or you can directly determine the potential of the electrode, as the standard hydrogen electrode potential is 0. But remember that there are so many difficulties in constructing the standard hydrogen electrode. The conditions which makes this electrode standard, all these conditions are responsible for the difficulties in setting up of the standard hydrogen electrode, or these are the disadvantages of the standard hydrogen electrode. We have said that hydrogen gas which we are using must be pure and dry, but it is not easy to obtain pure and dry hydrogen gas, and so it is not easy to obtain pure and dry hydrogen gas. This is the first disadvantage of the construction of standard hydrogen gas electrode. Now here this pure and dry hydrogen gas must be at 1 atmospheric pressure. When the working of standard hydrogen electrode is taking place, here to maintain the pressure of the gas at 1 atmosphere is not possible. That is, you can't say that during the working of standard hydrogen gas electrode the pressure of hydrogen gas is exactly equal to 1 atmosphere. Again we have said that the concentration of H plus ions must be equal to 1 molar. but remember that hydrogen gas is passing into the solution, and so the bubbles are created, and so some of the water will evaporate or will escape from that solution, and due to this the concentration of H plus ions cannot remain as 1 molar. So all these are the difficulties in setting up of standard hydrogen electrode, and to make these convenient here, by using this standard hydrogen electrode as reference electrode, the potentials of another electrodes are calculated or are determined. These are called as secondary reference electrode. So all these about the reference electrode and standard hydrogen gas electrode.